page 3 of differentiation. So remember that the derivative of a function is like the slope of a curve, gradient of a curve, okay? Now, if you extend the slope of the curve and make it into like a line, like I'm doing here, we call that the tangent line, okay? So a tangent line is a straight line. All lines in math are straight, but just to make it a point of emphasis, a straight line like stuck next to a curve, okay? Theoretically, it only touches at one point, and this straight line is called a tangent line, and it has the exact same slope as the curve at that point that it's touching, okay? So a lot of times for the derivative, we call it the slope of the tangent line or the gradient of the tangent line, and we can also actually find the equation of the tangent line if we want to. The normal line is a line which is perpendicular to the tangent line, okay? So it's exactly 90 degrees from the blue line, okay? So normal makes it sound like, oh yeah, it's just a regular line. But normal in math and physics has a special meaning. It's basically like 3D perpendicular, okay? So it's like sticking out, okay? So normal line is sticking out, and we can actually calculate the equation of the normal line too. Now, in our class, normal line is kind of like one of the most difficult things to do, and tangent line, which is the one that's along the curve, is one of the easiest thing to do because the calculator basically does all the work for the blue line and it does none of the work for the pink line. Okay, when we do the pink line, it's going to remind you a lot of Voronoi diagrams. Okay, so we're going to use the same equation as we did when we made Voronoi diagrams. We're going to use the point gradient form or the point slope form of a line. This format is in the formula booklet, so you don't need to memorize it. You just need to understand what it is. Basically, you're going to replace this, this, and this. Are you going to replace x and y? No, you're going to leave x and y as is because the equation of the line always has an empty x and an empty y not filled in, okay? By the way, what's the m? The m, short for mountain, is the slope, okay? And the x1, y1 is a specific point on the curve, okay? So why don't we just use slope-intercept form like we usually do? Okay, slope-intercept form is not really good for drawing a line through a point that is not on the y-axis, okay? So that's why we use this form, okay? Just like for Voronoi diagrams. Let's do number 1. Find the equation of the tangent to the curve, okay, keyword tangent, with the equation 2x squared minus 4 at the point where x equals 3. So it's always going to give us 3 pieces of information. One is they're going to give us the curve. The other is they're going to give us the location. And the other is they're going to say whether they want a tangent or a normal line. And tangent line, remember, is the easiest one. And the reason why is because the calculator does everything. We can go into y equals, and I'm just going to clear everything out here. And I'm just going to type the curve into y1 because that's what you always do, right? Whenever you have a function given to you in our class, the first thing you're going to do is you are going to type the function into y1, okay? Maybe you're also going to graph it. Let me just go to Zoom Standard because I was messing with the calculator. And then I'm going to graph it, okay? And it's a parabola, okay? So I want to draw a tangent line at x equals 3. X equals 3 is about here, so the tangent line would be kind of like that, okay? I am going to show you how to do that all with the calculator. So you just typed in the function. Then you're going to do second draw. Draws right there. Not one I use very often, so I need to look for it. And tangent, second draw tangent. So I just go to number 5. And it's going to draw me my tangent at, and then I'm going to type in 3, enter, and it's going to draw it at x equals 3. So the three things I need to know are the curve equation, I need to know whether I want a tangent or a normal line, and I need to know the location x equals 3. I type them all in, and it gives me my function, which is the tangent line equation. So it's y equals 12x minus 22. It says plus negative 22, but that's the same thing as minus 22, right? So that is my answer. Can't be any easier than that, right? Let's do another one. Now this one has a lot more context. It's got a seesaw, blah, blah, blah. Brian makes a seesaw for his children from part of a log and a plank of wood. The shape of the log can be modeled by, oh, they gave me the function. What do we do when we get a function? We type it in the calculator. So we even stop reading and we just type it in the calculator. Remember, a leading negative sign you're going to do with the little negative, not with the big negative, not with the big minus sign. Negative x squared plus 2x. You can just graph it if you want to. And then, let's see, the plank of wood is a tangent to the log at the point where x equals 1. Okay, so I am going to, so I guess this is like the base of a seesaw, and then he's going to put a plank across it. And so the plank is going to sit on this log at x equals 1. So I'm just going to do a second draw tangent at x equals 1, and then we're going to see what the plank of wood looks like. So we do second draw tangent, which is number 5, and then we're going to type in 1, because that's the location. And so at that point, the plank of wood is perfectly horizontal. How interesting. And then we look at the equation. It's y equals 0x plus 1. Isn't 0x the same thing as 0? So basically it's y equals 1. It's a horizontal line, right? Y equals 1. Okay, so there's the equation of the plank. It's just y equals 1. That was easy, right? A little bit tricky because y equals 0x plus 1 can be simplified to 1. Let's do number 3. Okay. A cyclist is cycling up a hill. The path of the bicycle on a hill can be modeled by part of the function f of x equals negative 2x squared. Whoa, they gave us a function. So what are we going to do? We're going to immediately type it in the calculator. Negative 2x squared. The leading negative needs to be this little negative sign. Negative 2x squared, and that's it. I can graph it now. Okay, and we're going to find the gradient of the wheel at the point where x equals 1. Okay, so here it's not asking me for the tangent line, is it? It's just asking me for the gradient of the wheel at x equals 1. If you remember, the gradient of the wheel is another way of asking me for derivative. What is the derivative at x equals 1? Well, so there's two ways you could do this. Let's do second draw tangent just to remember again how to do that. We do number 5. And we want the gradient at x equals 1. So we type 1, enter. And it actually draws the tangent line. And we can see that the equation is negative 4x plus 2. I'm just going to write that down just for my notes, okay? But the gradient at this point is not the whole thing. It would just be the negative 4, okay? So the gradient at this point is actually negative 4. And if you think back to the last page, we actually learned another way to do that. Second calc dy dx, number 6, is another way to do that. Now I can just type in 1, enter, and then it'll give me dy dx is negative 4. See, negative 4. So there's two ways you can do it now, right? You could just do second calc dy dx. It'll just give you the negative 4. But look, if you do second draw tangent, the negative 4 is inside the tangent line equation, right? Because the tangent line has the same slope as the derivative at that point, okay? What about part B? Find the gradient of the spoke that is perpendicular to the wheel when it touches the hill at the point where x equals 1. Okay, so I'm just going to draw a little picture here. This is a hill, right? And here's a certain point that we're worried about. Oh my God, this hill is very steep, right? So basically, they're asking us about this point here. They're saying, okay, if you're riding a bicycle up this hill, then the wheel is going to be like that at that point, right? And the spoke of a wheel is the radii that are coming out from the middle of the tire. I'm just going to draw the spoke I'm interested in right here, okay, in blue. So find the gradient of the spoke that is perpendicular to the wheel when it touches the hill at the point where x equals 1. So basically, isn't this blue line perpendicular to this green line? And what is the slope of the green line? It's -4, right? What is the slope of the blue line? It's perpendicular to -4. Now go back and remember, oh yeah, when I found perpendicular slopes, what I did was I took the original slope and I put -1 over the original slope. So I did -1 over -4. And then I simplified it. So then it became 1/4. Okay? So this blue spoke, the derivative or the gradient of it is 1/4. Okay? 1/4. So this particular problem, it didn't ask me for the tangent line equation. It didn't ask me for the normal line equation. It just asked me for the gradient at a certain point. It would be -4. And it asked me for the gradient that is perpendicular to that gradient. We call that the normal, right? Perpendicular. It would be 1/4. Okay, so -4 and 1/4 are perpendicular gradients. Okay, if you remember back from Voronoi diagrams. I think this is the last one. Find the equation of the norms to the curve with the equation 3x squared minus 4x plus 5 at the point 1, 4. Okay, so there's a couple steps to this. First step is we copy down the formula, this formula right here, okay? So it's basically y minus y1 equals m times x minus x1. By copying down this formula, you probably already get 1 point, okay? Now, let's do the slope first. It would be exactly like this procedure here. So first thing we're going to do is, since they give us a function, what do? We always type it in the calculator. So we're going to put it in the calculator, 3x squared, and then we're going to put minus 4x, and then we're going to do plus 5. And then we're going to graph it. Okay? And then we want to know the equation of the normal to the curve at 1, 4. Okay? So where is 1, 4 anyway? I'm just going to do a trace to see where it is. So if you remember, you just do trace 1, and it'll show you where the point is. Trace 1, enter. And so the point is here at 1, 4. They already gave me the coordinates, okay? 1, 4, right? Okay, so here's the point where I want to draw the normal to the curve. If you remember, the tangent to the curve would look kind of like that, right? I'm going to draw a little sketch here. So it looks like that, right? There's my point. The tangent to the curve would look kind of like that, right? The normal to the curve would just be perpendicular to that, like that. Okay, I'm going to label it N. Okay, that's the normal. So in this case, first thing I want to know is I want to know what this slope is, this slope here. How do I find it? I just need to find the derivative. Second calc dy dx, which is number 6, and then I just type 1, enter. And it tells me that the derivative is 2. So the derivative of this is 2. What would be the derivative of the normal line? It would be -1 over 2. Okay, so this is my normal slope. So let me just say, okay, the tangent slope is m equals 2, and the normal slope would be m perpendicular equals -1 over 2. And I'm going to put the perpendicular slope into this m. Okay, what am I going to put into x1 and y1? I'm going to put 1 and 4. Okay, so let me rewrite it all. I'm going to put y minus 4 equals -1/2 x minus 1. What did I put into m? I put in the perpendicular slope. The derivative slope was 2. The perpendicular slope was -1 over 2. What did I put into x1? I put 1. What did I put into y1? I put 4. If you can see, when we did second calc dy dx, we got most of the information right here, right? The 2 needs to be made perpendicular, so we put -1 over 2, but the 1 and the 4 also come out if you have the newer calculator. Okay, so here is my resulting normal line equation, which is what they asked for. Okay, look at what they asked for. They told me three things. They said, do they want the normal line or the tangent line? They unfortunately said normal line, which means I need to do a little bit of manual work. If they would have said tangent line, then I could just do second calc or second draw tangent and I would be done, right? And they also gave me the function and they gave me the location. Okay, so this was a relatively easier one, and then we're going to do more challenging ones next page. I think that's it for this page though. Yep.